Now, counting principles can be used to explain why in poker one hand beats another hand. So in poker, typically you have what's called a 5-card draw, which is the player will have 5 cards. And in poker, a hand that is less likely to occur will beat a hand that is more likely to occur. So down here I have a listing of the hands in poker. So royal flush would be getting a 10, jack, queen, king, and ace, all of the same suit. Okay, so they would either all be diamonds, or they're all hearts, or something like that. A straight flush would be 5 cards in sequence, all of the same suit. So when this asterisk means that an ace can either be considered higher than a king, or it can also be a 1 and occur lower than the 2. So here is an example of a straight flush over here involving diamonds going from ace up to 5. Okay, so 4 of a kind, that'd be 4 cards of 1 rank plus another card. So for instance, maybe you have the 8 of diamonds, the 8 of hearts, the 8 of clubs, and the 8 of spades. Okay, so you have the 8s all in the same rank between the different suits, and then you've got some other random card. A full house would be 3 cards of 1 rank and 2 of another. A flush would be all 5 cards are from the same suit, so you've got 5 hearts, or you've got 5 spades. A straight would be any 5 cards in sequence, so they don't care about the suit. So for instance, here is an example of cards in sequence, but in this case they're all diamonds. What a straight would be is it doesn't matter what suits they are, but they are in sequence. 3 of a kind would be 3 cards of 1 rank and 2 cards that are different from each other. 2 pair, that would be 2 cards of 1 rank, 2 cards of 1 rank, 2 cards of another rank, and then a 5th card that's totally different from the first 4. A pair would just be 2 cards of the same rank, and the other 3 cards are all random, or finally you got nothing. So let's go ahead and use counting principles to figure out the likelihood of getting some of these hands. So in this one, how many ways can a 5-card poker hand be drawn from a standard deck of cards? So when you're pulling cards out of a deck, order does not matter. Okay, so these are going to employ the idea about combinations. So we're going to have 52 cards total, and we want to pull 5 of them for our hand. So our N would be 52 and our R would be 5. So if you throw that in your calculator, you get that there are 2,598,960 possible hands in poker. Alright, so that would be kind of like the total number of hands, and moving forward in probabilities, that's going to be the size of our sample space. So out of all of these possible hands, let's find the number of ways for some of these special things to be happening. So the first thing we're going to look at is the number of different ways we can get a full house when drawing 5 cards. So here is a generic example of a full house. So the full house has 3 cards of 1 rank. In this instance, we have 3 cards that are 10s, and we have 2 cards of another rank, in this case 7. But for this question, I just don't want it to be 10s and 7s. We're just going to do it in general. How many ways is there for this to happen? So let's break this out for the 3 cards that are going to be the same rank. Okay. So out of this one, there are 13 ranks possible. So let's say you lock in what rank you want it to be. So for instance, maybe your rank is going to be 10s. Okay. So out of the 4 possible 10s, you're going to need 3 of them. Okay, so once you lock in your rank, this would be the number of ways of getting 3 of those cards out of the 4 possible. So overall then, this would be then once you lock in your rank how many choices you have, and then we need to multiply that over the different possible ranks, because it's not, we don't necessarily need to get 10s, you have 13 possibilities that you could have there. So this is then going to be 13 times, and then this computation gives you 4. So there are 52 ways of getting the 3 cards of the same rank. So let's break this down to the other case, which is the 2 cards of the same rank. Okay, now this has to be a different rank than what you have up here. Right, so you can't, for instance, you know, if you have 10s here, you can't be looking at 10s down here. So now you only have 12 ranks possible. And the argument is also very similar here. Out of the 4 possible, you need 2 of them. Okay, so that's going to be 4, choose 2. So then overall here, that's going to be, you've got 12 ranks possible, where each one of them can be selected in that many ways. So this is going to then give me 12 times 6, or 72 possible ways. So then we just use the counting principle to pull all this together then. So there are 52 ways of selecting the 3 cards. There are 72 ways of then following that with our 2 cards. So then overall it's going to be 52 times 72, or 3,744 ways that we could get a full house. Alright, so out of the, over 2 million possibilities, there's not very many ways to do that. So that's kind of why that's a special hand. So I'm going to go ahead and record that up here. There were, for the full house, 3,744 ways to do that. Alright, now for the next question. Determine the number of different ways that we can obtain a flush when drawing 5 cards. So for a flush, we are specifically looking at this case. All 5 cards are from the same suit. There are very special flushes, a royal flush and a straight flush, but we don't want to count those. We just want all 5 cards being from the same suit. So let's start kind of organizing that. So first we need to pick the suit for the card. So there are 4 suits possible. Do you want them to be all spades, or do you want them to be all diamonds, whatever. Now, out of the 13 cards that are in the suit, you're going to need 5 of them. So that would be then, out of the 13 cards, you want to choose 5 of them. Okay, so the argument here then, so 13 choose 5 is 1,287. So we would kind of approach this very similarly how we did the previous one. So 4 times 1,287 gives you 5,148. Now the difference on this one though is this counts all the different possible ways of getting a suit, but depending on what cards you end up pulling, those actually fall into very, very special cases. So we do not want to count if we have a royal or a straight flush here. Okay, so yeah, it's a flush, which was counted here, but it's a very special type of flush. So let's kind of look up here and see how many ways we can do royal and straight flushes. So royal would be 10, jack, queen, king, and ace, all of the same suit. Okay, so that would then be they would be these 5 cards that are all spades, or these 5 cards which are hearts. They could be these 5 cards which are all diamonds, or these 5 cards which are all clubs. So a royal flush, there are 4 ways to get a royal flush. For a straight flush, that would be 5 cards in sequence, all of the same suit. So, like for instance, here's an example of a sequence. So you could have the ace, 2, 3, 4, 5. So that would be a possible sequence. The run could start at 2 and then go through 6. It could start at 3 and go through 7. Okay, so we can keep going through here. So it could start at 4, 5, 6, 7, 8, 9, or 10. And then if it started at 10, it would be the jack, queen, oh, that was supposed to be a queen, king, ace. So, but this one is the very special one. This is the royal flush, right? So we don't want to count that. So for each of these possible runs, it could be in any of the 4 suits. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9 ways of doing a run between all of the different suits. So this would be 9 times 4, or 36 ways of getting a straight flush. So out of all of the possible flushes, we don't want to count the royal flushes or the straight flushes. So there are 40 types of arrangements that we don't want to include here. So we're going to subtract out the 40 that we don't want to count, and then that would leave us the count for how many ways there is to just get a flush. So that's going to be 5,108 ways. So you're seeing here then the full house beats a flush because this is less likely to happen. Okay, and then that's going to be true. You can repeat counting arguments like that for all of these different cards.